Hi everyone, welcome to my YouTube channel. In this video, we are going to continue class 10th science and we are going to continue the chapter light reflection and refraction. This is part number 11. In this part number 11, we are going to write the ray diagram for concave and convex lens. First, let us write the ray diagram for convex lens. So now here for convex lens 6 positions will be there. So the 6 positions are when the object is kept at F1, that is the first position, between 2F1 and F1 second position, at 2F1 third position, behind 2F1 fourth position, infinity fifth position, object kept between optic center and principal focus, that is sixth position. So now let us see what type of image will be formed when object is kept at different positions. So the first position is when the object is kept at F1. So here we have kept the object. Let us see what will be the position, nature and size of the image formed when the object is kept at F1. So when the object is kept at F1, first position, you have to recall the concave mirror. Because in concave mirror, if the object is kept at F, the image will be formed at infinity. Here also, if the object is kept at F1, the image will be formed at infinity. So now I have kept the object at F1. See here, this is the F1 and I have kept the AB object at F1. So now let us use the rule, the light ray which is parallel to principal axis. So this is the light ray which is parallel to principal axis after refraction. So mirror reflection and lens refraction. After refraction, that is the light will get bent when it travels from one medium to another medium. So now the light ray which is parallel to principal axis, after refraction it passes through principal focus. The light ray which is parallel to principal axis, after reflection it passes through principal focus. So this is one light ray. Then another light ray, the light ray which passes through optic center. So the light ray which falls on the object and passes through object, that is optic center, it will never deviate. So it passes through optic center only. Therefore the image is formed at infinity. So this is the first ray diagram. What is the position of the image? So image is formed. So where does the image is formed? The image is formed at. So image is formed. So where does the image? The image is formed at. Image is formed at infinity. That is the position of the image. What is the nature of the image? So image nature is, image is real and inverted. So real and inverted image is formed. Then since the image is formed at infinity, so image is highly enlarged. Image is highly enlarged. So highly enlarged image is formed. So like this we have to write, one is position, nature and size. Position, image is formed at infinity. Nature, real and inverted. Size, image is highly enlarged. So this is position number 1. So now let us move for the second position when the object is kept between 2F1 and F1. So now let us see what happens when object is kept between 2F1 and F1. So you please recall for mirror, concave mirror. When the object is kept between center of curvature and principal focus, the second position, image will be formed at behind C. Agar illi image will be formed behind 2F2. ಅಲ್ಲಿ ಬಿಹಾಂಡ್ ಸಿ ಅಂತೀವಿ, ಇಲ್ಲಿ ಬಿಹಾಂಡ್ 2F2 ಅಂತ ಕರಿತೀವಿ. ಸೊ ಹಾಗಾದ್ರೆ ಆಬ್ಜೆಕ್ಟ್ ಈ ಕಡೆ ಇದ್ರೆ ಇಮೇಜ್ ಈ ಕಡೆ ಆದ್ರೆ ರಿಯಲ್ ಅಂಡ್ ಇನ್ವರ್ಟೆಡ್. ಸೊ ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ಪ್ಲೇಸ್ಡ್ ಬಿಟ್ವೀನ್ ಸೆಕೆಂಡ್, ಇಟ್ ಈಸ್ ಪ್ಲೇಸ್ಡ್ ಇನ್ ಸೆಕೆಂಡ್ ಪೊಸಿಷನ್. ಸೊ image 1 2 3 fourth position, image is formed at fourth position. So now let us write the ray diagram. The light ray which is parallel to principal axis, after refraction it passes through principal focus. So after refraction that light ray will pass us through principal focus. This is one. Then second light ray is the light ray which passes through optic center. It will never get deviate. So the light ray which passes through optic center, it will never deviate, and where the two images two light ray they will get meet, so there the image is formed. Therefore image is formed behind 2f2. ಸೊ ಇಮೇಜ್ 2f2 ನ ಹಿಂಭಾಗದಲ್ಲಿ ಉಂಟಾಗುತ್ತೆ. ವಾಟ್ ಈಸ್ ದ ಪೊಸಿಷನ್ ಆಫ್ ದ ಇಮೇಜ್? ಸೊ ಇಮೇಜ್ ಪೊಸಿಷನ್ ಈಸ್ image is formed behind 2f2. What is the nature of the image? Since the image is formed toward this side, so image is real and inverted. A real and inverted image is formed. Then what is the size of the image? As compared to the size of the object, image size is enlarged. So now let us write image size is enlarged. So these are the 3 points that you have to write regarding when the object is placed between f1 and 2f1. This is the second position. So now let us move for the third position when object is kept at 2f1. So again you have to recall concave mirror. When object is kept at center of curvature, image is also formed at center of curvature only. Now if I keep the object at 2f1, image will be formed at 2f2. ಸಿ ನಲ್ಲಿಟ್ಟರೆ ಸಿ ನಲ್ಲೇ ಆಗುತ್ತೆ ಅಂದರೆ 2f1 ನಲ್ಲಿ ಇಟ್ಟರೆ 2f2 ನಲ್ಲಿ. If object is kept at 2f1, the image will be formed at 2f2. So now let us follow the rule. The light ray which is parallel to principal axis, after refraction it passes through. ಇದು ಥರ್ಡ್ ಪೊಸಿಷನ್ ಆಗಿರೋದ್ರಿಂದ ಆಬ್ಜೆಕ್ಟು ಥರ್ಡ್ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಇದ್ರೆ ಇಮೇಜು ಕೂಡ ಥರ್ಡ್ ಪೊಸಿಷನ್ ಅಲ್ಲೇ ಇರಬೇಕು. ಇಫ್ ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ಫಾರ್ಮ್ಡ್ ಅಟ್ 2f1, image will be formed at 2f2. So now the light ray which is parallel to principal axis, after refraction it passes through principal focus. So this is one light ray. Now the light ray which passes through optic center. So the light ray which passes through optic center, so it will never get deviate, and hence it will never get deviate. So it passes through optic center only. So where the two light rays they will meet, there the image is formed. Therefore the image is formed at 2f2. So this is B dash and this is A dash. So if object is kept at 2f1, the image is formed at 2f2. So ಎರಡು ಲೈಟ್ ರೇ ಎಲ್ಲಿ ಮೀಟ್ ಆಗುತ್ತೋ ಅಲ್ಲಿ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. So that is, let us write the position. The position is image is formed. If object is at 2f1, the image is formed at 2f2. Nature, image is real and inverted. Then what is the size of the image? Image size is same as object size. Both image and object size is same. So image size is same as object size. So this is what we have to write for. That is when object is kept at 2f1, that is the third position. If the object is at third position, image is also formed at third position only. Therefore if object is at 2f1, the image is formed at 2f2. So now let us move for the next one. That is when object is kept behind 2f1. Beyond 2f1 means 1, 2, 3, fourth position. If object is kept at fourth position, the image will be formed at the second position. This is the first and this is the second. So image will be formed at formed between f2 and 2f2. Between f2 and 2f2 image will be formed. So now the light ray which is parallel to principal axis, after refraction it passes through principal focus. It passes through principal focus. This is one light ray. Next, one more light ray I will take. The light ray which passes through optic center. The light ray which passes through optic center, after refraction it passes through optic center only. So now here the light ray which passes through optic center, it passes through optic center only. So where the two light rays they meet, there the image is formed. So here the image is formed between, so B dash A dash is the image, and that image is formed between F2 and 2F2. So image is formed between F2 and 2F2. So now let us write the position. What is the position? So when object is kept behind 2F1, therefore the image is formed. Image is formed between F2 and 2F2. This is position of the image. Then what will be the nature of the image? So image is real and inverted. So real and inverted image is formed. Then what is the size of the image? So image is diminished. So a diminished andre the image will become, its size will be reduced. That is diminished in the sense the image size will get reduced. Therefore the image is diminished. So if object is this much size, the image will be smaller. So the image size will be lesser than the object size. That means image is diminished. So this is fourth position. So now let us move for the fifth position, that is when object is kept at infinity. So let us move for the fifth position, when the object is kept at infinity. So here the object is kept at infinity. So this is the fifth position. Again, if you recall it, when the object is kept at infinity in a concave mirror, the image will be formed at principal focus. So here if the object is kept at infinity, the image will be formed at f2. So infinity f, that is f means principal focus, means here the image is formed at f2. The light ray which is parallel to principal axis, after refraction it passes through principal focus. The light ray which is parallel to principal axis, after refraction it passes through principal focus. Then the light ray which is parallel to principal axis, after refraction it passes through principal focus. So now where the two light rays they will meet, the two light rays they will meet at f2. So now image is formed at f2. So now what is the position of the image? So image position is, image is formed. So where the image is formed? The image is formed at f2, that is principal focus. What is the nature of the image? The image nature is, image is real and inverted. A real and inverted image is formed. What is the size of the image? So image size is highly diminished. Image size is highly diminished. So highly diminished in the sense the image size will become too much small, that is called highly diminished. So these are the points that you have to write regarding when object is kept at infinity. When object is at infinity, the image is formed at principal focus f2. Therefore, the image is real and inverted, and the size of the image is highly diminished. So the image become too much small. That is, point sized image will be formed. So this is about position number 5. Now let us move for position number 6. That is when the object is kept between optic center and f1. So now when the object is kept between optic center and F1, so let us see where the image will be formed. So now the light ray, so object is kept between optic center. This is the optic center and this is F1. So now how the image will be formed, let us see. The light ray which is parallel to principal axis. Actually after refraction it should pass us through principal focus. Actually it should pass us through principal focus. The light ray after refraction it should pass us through, actually its path should be like this. This is the actual path, but instead of that one the light ray will move in this path. So that is the path. Actually after refraction it should move like this. Then the light ray which passes through optic center. The light ray which passes through optic center after refraction again it passes through optic center. So no deviation. So now this is what we have to write. So this is the correct path that we have to write, but the light ray will move like this. So now, so where the image is formed, the image where the two light rays they meet, there the image is formed. So image will be formed like this. Now position, so image is formed. So now image is formed. So where the image is formed, the image is formed, actually it will be formed, this is 2F1. So image will be formed behind 2F1. So image will be formed behind 2F1. Then nature, since object and image is it is formed since the image is formed where the object is kept, the image is virtual and erect. So image formed is virtual and erect. So when compared to object size, image size is enlarged. Image size is enlarged. When compared to object size, image size is enlarged. That means the image is formed behind 2F1. So this is the sixth position that we have to study. 5 position, real and inverted image is formed. And the sixth position, virtual and erect image is formed. So this is about convex lens. Now let us move for concave lens. So in concave lens, we are going to take two positions. So we are dealing with the two position. So concave lens. One, when object is kept at infinity. Let us see what happens when object is kept at infinity. So we are keeping the object at infinity. So when the object AB is a object and that object is kept at infinity. When the object is kept at infinity, the light ray which is parallel to principal axis after refraction. So after refraction, actually it should passes like this. The light ray will get diverge. Actually light ray itara diverge agbeku. So but instead of that one, the light ray will passes through principal focus F1. Then the light ray which is parallel to principal axis after refraction, that light ray should get deviate. So actually it should move in this direction, but its path continue like this and that light ray passes through principal focus. So here also after the light ray which is parallel to principal axis after refraction, it should passes like this. So its path should be like this. So it should get deviate like this. So it should get deviate like this. It should deviate in this direction. Instead of that one, it passes through principal focus. So its deviation should be like this. But instead of that one, the light ray will pass us through principal focus. Therefore, when object is kept at infinity, so image is formed. So image is formed. Where the image is formed? The image is formed at F1. Since the image is formed at F1, so image is, since object and image are both lies on the same side, so image is virtual and erect. So image is virtual and erect. What is the size of the image? So image size is highly diminished. Image size is, because when object is kept at infinity, so image size is highly diminished. So highly diminished image will be formed. So this is the first position when the object is kept at infinity. So one more position will be there when the object is kept near the lens. So let us see what happens. That second, only two cases will be deal with concave lens. So the first position, object is kept at infinity, and the second position when the object is kept near the lens. Let us see what happens when object is kept near the lens. So when object is kept near the lens, the light ray which is, so let us keep the lens at near, let us keep the object near the lens. So now let us move for when the object is kept near the lens, the light ray which is parallel to principal axis, after refraction, its path should be like this. Its path should be like this. This is the, actually it should diverge like this, but its path will continue like this. Then this is one. Then another one is the light ray which passes through optic center. The light ray which passes through optic center will never get deviate. So here the image, where the two light rays meet, there the image is formed. So now the image is formed between optic center and F1. This is AB and this is A dash B dash. So now position, the image is formed. So image is formed between optic center and principal focus. This is position. Then since the image and object are they are in same side, so image is virtual. That means in concave lens, virtual image is formed. So image is virtual and erect. In both the cases also the image is virtual and erect. So what about the image size? So image size is image size is diminished. Highly diminished first case. Second case, image size is diminished. So these are the 8 ray diagrams that we have to write for concave. For convex lens, 6 ray diagram, and concave lens 2 ray diagrams. So by this all the ray diagrams related to mirror and that is related to mirror and lens is finished. So in the next video we are going to deal with lens formula, and let us solve some numericals related to lens, and along with that one let us study about power of lens. So by solving the numericals and power of lens, this chapter will be completed. So thanks for watching my YouTube channel. Still those who have not subscribed my channel, please subscribe it. Those who already subscribed, please watch my videos, like my videos and share my videos. And don't forget to press the bell icon to get the notification for the next video. So thanks for everyone for your great support. Once again, thank you very much.